All right, let's start to use our unit circle now to build the sine function. So remember that the input, or the x-axis, in a trig function represents the angle. So you'll notice if you look at the x-axis on this graph, you'll see these angles here from 0 to 360. The y-axis then represents the trig value, which of course in the case of sine would be the ratio that we get when we do opposite over hypotenuse. Notice that it has a maximum of 1 and a minimum of -1. Now what else can we think of this representing? It's also the y-coordinate on the unit circle. So when we make the unit circle, our y-coordinate represents the sine value. So that's what we're going to use to help us draw our unit circle, or sorry, draw our sine curve. So let's recall that if we go around to 0, 90, 180, and 270, and I think I need to kind of scoot this down on my drawing to make it all fit, there we go, then what is the sine value, or what is the y-coordinate at each of those angles? So the y-coordinate at 0 is 0, at 90 it's 1, at 180 0, and at 270 -1. So if we plot those points, 0, 0, 90, the y value is 1, that's our maximum value. At 180, the sine value, the adjacent or the opposite side, is back down to 0. No vertical side when we're straight on this horizontal line. Then at 270 we're down to -1, and then back at 360 we're back to 0, or at the same place as we were with 0. Now let's look at our 30-degree reference angle. So if we want to go back one here to our unit circle, we'll notice that at the 30-degree reference angle, the y-coordinates are all either positive or -1/2. So looking at 30, 150, 210, and 330, we see positive 1/2 in quadrant 1 and 2, and -1/2 in quadrants 3 and 4. So we notice the sine value is positive here in quadrants 1 and 2, so it's kind of increasing from 0 to 1, and then, you know what, I don't really like the way I've labeled this, and I know that you've already done this, but I'm going to just make this a little bit less busy here. So here's 0 degrees, 90 degrees, 180, 270. So the sine value here is 0, 1, 0, -1. So as we go from 0 to 1, we have all positive sine values, and as we go 1 back to 0, we still have all positive sine values, they're just getting smaller. Then as we go from 0 down to -1, we have all negative sine values, and -1 back to 0, we still have negative sine values. So notice here, from 0 to 90 degrees, my trig values are going up, all positive. From 90 degrees to 180, they're going down, but still positive. From 180 to 270, negative sine values, and from -1 up to, or from 270 up to 360, still negative sine values. All right, so we talked about every place where we have a 30-degree reference angle, it's either positive or -1/2. So let's put 0.5 on our graph, and let's put -0.5 here. So positive 0.5 is going to occur at 30 and at 150. -1/2 is going to occur at 210 and at 330, because those are all of our angles that have a 30-degree reference angles. Now if you go back to our and look at the 60-degree reference angles, you'll see for the 60-degree reference angles, the y-coordinate is always either 0.87 or -0.87, because that corresponds to the square root of 3 over 2. So I'm going to mark 0.87. It's just slightly less than 0.9, so here's 0.87 and -0.87, kind of right in here. And so my two angles that have that trig value would be 60 and 120 on the positive end, and 240 and 300 on the negative end here. Okay, so those are the values where sine equals 0.87. The last one is the 45-degree angles, and that's where sine was square root of 2 over 2, 1 over square root of 2, which is about 0.7. So I'm going to put 0.7 and negative 0.7 here. And those occur at the 45-degree angle. So 45, 135, 225, and 315. So notice there's a little space here between 0 and 30 and like 150 and 180, and there's not any points in between there because the 30, 45, and 60 are all kind of close together. So now we are able to draw our curve. I'm going to put it in a different color so the points still show up, but you can do however you want to. And I want you to notice how elegant of a curve this is. It looks like an upside down bowl kind of in the above the x-axis, and kind of a right side up bowl below the x-axis, like this. I want you to notice that this up where we're going up over here is quadrant 1. This section corresponds to quadrant 2. Down here, this section corresponds to quadrant 3, and this section corresponds to quadrant 4. So this is our sine curve.